Hi, and welcome to the 7th course dedicated to the GAMA platform. In this course, we will show you how to explore the parameter space of a model and how to calibrate it. During the last course, we saw how to define a model. We saw as well how to define in a specific experiment parameters and different types of outputs, such as map, monitor, and charts. We will see now why we need to explore the model, and in particular its parameter space, and how. Indeed, once the model is written, the work of the modeler is not finished. As most of agent-based are stochastic, it is important first to have an idea of the impact of the stochasticity and on the simulation results. Another important study to carry out is the impact of the different parameters on the simulation results. For example, in our model, we can study the impact of the mobility on the infection propagation. At last, we have real data concerning the output of the reference system. They can be used to calibrate the model. In our model, we have real data concerning the infection propagation. We can try to define the best values for the infection distance and probability parameters to fit with these data. Concerning the impact of the stochasticity, the simplest way to study it is to execute numerous successive simulations run with the same parameter values to compute the mean and the standard deviation of the model outputs. As it is fastidious to execute successive simulation runs with the graphical interface of GAMA, we will use a batch experiment. In order to help modelers to explore the parameter space of a model or to calibrate it, GAMA proposes a specific type of experiment called batch. A batch experiment allows to execute numerous successive simulation runs with given parameter sets. A batch experiment is defined like a GUI experiment, except that modelers have to define an ending condition for the simulation and can define the number of simulation runs that will be executed for a parameter set. Inside a batch experiment, the modelers can define the parameters they want to explore, the exploration method that will be used, and some specific behaviors and outputs. For our model, we choose to study the impact of stochasticity. We choose to define a new batch experiment called test robustness that will execute 10 simulation runs. Each simulation will end after 2 hours. In this experiment, we define a reflex that will be activated. We add a new variable called vals that will be a list of float and that will contain the infected rate of each run. Then write in the console the mean value of the vals list and its standard deviation. We then push the Test Robustness Experiment button to load it, then the Play button to run it. We can observe in the console the results obtained for the different simulation runs as well as the computed mean and standard deviation. We can observe that the value of the standard deviation is not negligible with respect to the computed mean. It means that it is important to take the stochasticity impact into account when exploring and calibrating the model. We are now going to study the impact of the parameters on the simulation results. Exploring the parameter space of a model can be used for many purposes, such as correct the model, analyze its sensibility to the variation of the parameter values, and calibrate the model or discovering emerging properties. It is thus a very important step after developing a model. In our model, we are interested in studying the impact of the mobility on the simulation results. For that, we have first to define the initial situation that will be for us the same as the one of the GUI experiment. For the stopping criterion, we choose to end the simulation after 2 hours. In this example, we have only one parameter to explore, the probability to leave a building. We define 5 possible values for this parameter: 0, 0.01, 0.05, 0.1, and 1.0. Concerning the exploration method, we use an exhaustive exploration. We will execute 2 simulation runs per parameter set. Parameters in batch experiments are defined exactly like in GIS experiment. Concerning the possible values that can take a parameter, the modelers can use 2 ways to define them, either explicitly using the among facet or by giving a minimum or maximum and a step value. As we want to be able to explore the impact of the mobility, we define for that a new global variable called proba_leave that is used by people agents to define the probability to leave a building. We define a new batch experiment called explore model. Each simulation will end after 2 hours, and each parameter set will be tested twice. In this experiment, we define a new parameter concerning the proba_leave variable with 5 possible values: 0, 0.01, 0.05, 0.1, and 1.0. We define as well a new reflex called save results. In this reflex, we write in the console the values of the proba_leave variable and the infected rate variable. Then, we save the value of these 2 variables in a CSV file. A line will correspond to 1 simulation run. We then push the Explore Model Experiment button to load it, then the Play button to run it. We can observe in the console and in the CSV results file the results obtained for the different values of the proba_leave parameter. We can observe that the value of this parameter has a real impact on the infected rate. We want now to calibrate the model, in our case, to find the best values for the infection distance and probability to fit the real data that we had concerning in the infected rate. Indeed, we know that during the last year the infected rate after 2 hours was 0.5. To calibrate a model, it is important to define a good indicator, often called fitness, to define the quality of a parameter set. In our case, it will be the difference between the simulated infected rate and the real infected rate after 2 hours. In our model, we are trying to calibrate the infection probability and distance. The initial situation will be for us the same as the one of the GUI experiment. For the stopping criterion, we choose to end the simulation after 2 hours. We define 2 parameters: the infection distance that will have for a minimum value 1, for maximum value 20, and for the step 1, and the infection probability that will have for minimum value 0.01, for max value 1.0, and for the step 0.01. Concerning the exploration method, we use a generic algorithm that will search to minimize the absolute difference between the infected rate and 0.5. We will execute 3 simulation runs per parameter set. In GAMA, the exploration method can be specified by using the method statement. We can then define the expression to minimize or to maximize. Several exploration methods are available: exhaustive search, generic algorithm, hill climbing, simulated annealing, local taboo search, and reactive taboo search. As we want to be able to calibrate the infection distance and probability, we define for that two new global variables called infection distance and proba-infection that are used by people agents in the infect reflex. We define a new batch experiment called calibrate model. Each simulation will end after 2 hours. Each parameter set will be tested 3 times. In this experiment, we define a first new parameter concerning the infection distance variable with a minimum of 1.0, a max of 20.0, and a step of 1. We define a second new parameter concerning the proba-infection variable with a minimum of 0.01, a max of 1.0, and a step of 0.01. Now we define the exploration method. We want to use a genetic algorithm for the parameter exploration with a population of 3 parameter sets and 5 generations. This algorithm will try to minimize the absolute difference between the infected rate and 0.5. We then push the Calibrate Model Experiment button to load it, then the Play button to run it. We can observe in the batch panel the fitness of the different tested parameter sets as well as the best fitness found. It is also possible to know the parameter set corresponding to the fitness value. In our example, the best fitness found is 0.043, which is quite good, with a value for the proba-infection of 0.96 and a value for the infection distance of 11 meters. The batch mode is very useful when exploring small parameter sets or when the computation time required by a simulation is not so high. If more complex parameter space exploration methods are required, a possibility is to use R. Indeed, it is possible to run a gamma simulation with a given parameter set from R. Gamma is also compatible with the OpenMole framework that allows to run simulation on a cluster or a grid of computers.